Okay, so this problem asks us to find all possible exact solutions. So it's very similar to the last video, but this time we're doing sine t equals 1/2. Now remember, we're solving for t. Okay, so think about, all right, where is sine equal to 1/2? Well, in the first quadrant, right? So that's pi over 6. Now you could have a question, why aren't you doing it in degrees? Why are you doing radians? They usually put it in radians. I don't know that there's a specific reason, but okay, but the sine of pi over 6 is 1/2, so that would be 1. The other quadrant where sine is positive is over in the second quadrant. And so you're going to need that angle, which is going to be 5 pi over 6. So because we're doing all possible, we have to keep adding 2 pi to those. So our solutions, t equals, well, pi over 6 plus or minus some 2k pi. And then 5 pi over 6 plus or minus 2k pi. And then that represents all the possible solutions. Okay. Now you might be saying, well, didn't we already do stuff like this? Didn't we do like an inverse sine? Remember when we have inverse sine, so if you have inverse sine of 1/2, the restrictions for that are it has to be between negative pi, I'll say equals theta. Theta has to be between negative pi over 2, and pi over 2. So remember, it's a different restriction, and it's very limited. They do one where it's negative and one where it's positive, just 2 quadrants. Here we're looking for any quadrant where there's a positive sine value of 1/2, okay? So it's a little bit different system. The writing is different. Okay, this means something different than what this means. I mean, it's kind of the same idea. You're looking for angles that have a sine of 1/2, but the notation indicates domain, okay? Or the directions, like in the equations we're solving. So just this is different. This is different. And it has to do with our definition of inverse sine, okay? All right, just in case you were wondering.